There are so many components that are required to build a whole motorcycle. A large majority is going to be within the frame and the bodywork. But it's the external components that are most visible, that are most heavily controlled by the industrial design team. And these can also be the most fun and complicated components to model and design. It really depends on how creative you want to be. I'm going to keep this one simple, and in the future we'll make something a bit more interesting. So to start, I thought I'd show a little trick that some people probably use, which is importing or inserting an image onto the canvas in your 3D workspace. This could be useful as a 3D reference if you want to kind of copy the shape of something. If you have side view, top view and front view, it's very useful to recreate these objects. Now the image I've imported is not to scale, so I'm just doing a measurement between the front and rear wheel for the wheelbase. Knowing what the wheelbase is, I can divide that by the measurement to know how much I need to scale up this image. So I can now go back into the feature tree and edit where I inserted the image and add a scale factor of 200.7. Now I'm just going to drag the image until the rear wheel is on the 0 point. There's a couple of reasons why I'm doing this. Firstly, I'm going to be using this image as a reference for the shape of the rear pillion hanger, the position of the feet and the mounting points. The second reason is that in industry, if you're working on a motorcycle like this, you'll likely have the whole motorcycle in CAD from the very beginning, although it may be roughly modelled. And when we create these components, we want to position them without creating external references. So within the part will be its own coordinate system where it's mounted, and then it will have a global coordinate system which would be the same as the motorcycles, which means you could drop the part into the assembly and just mount the global coordinate system back to the bike's global coordinate system, and it would fall into place. So right now I've just made two new components, and this is the front and rear boss in the frame where the pillion hanger is mounted to. There'll be a third component which I'm going to position, which is the pillion peg. So I'm using this as an example of how the assembly might be in industry, with the components that you're going to be mating up to already being within the assembly. Now in the UK, the most common CAD program used in the motorcycle industry, I would say, would be Creo. We don't want to have references between our part models. So if I was to be modeling our pillion hanger here, I would probably copy the geometry of these two bosses and the pillion peg into my part model. But this would be external references. However, you can then change this surface geometry to independent geometry, which breaks the link and just makes it a surface feature within your model. Now would be an ideal time to make any final adjustments to the positions. Okay, I'm now ready to add the pillion hanger component. I'm just going to put in a dummy shape so I can mate it and position it back to the pillion hanger bosses in the frame. Now if I was actually modeling this part for a real motorcycle, I'd probably be including some other geometry for reference. Things like the weld bead around the bosses in the frame, any bodywork that may be nearby, just to make sure that we're not interfering with any existing geometry. And if I know the tolerance stacks for these components and these details, I could use that to create an additional offset to make sure that I'll be clear even in the worst of cases. Okay, and now I'm ready to start modeling. I'm starting with splitting this into a number of components. So we have two bosses at each mounting location. We have the clamp feature for the pillion peg, and then we have the arms, the struts, the members between the bosses to the clamp feature. In order to create the peg mounting feature, I would offset a plane from the parts datum. You'll notice that during this sketch I'm often referencing back to the pillion peg, but this would be creating the external references which we don't want, which is why I then delete these references and then reposition it back to the parts coordinate system. I'm going to extrude this in both directions with a draft. Now I want to cut out the internal surface of this part, and I'm going to do that by first creating a plane along a path using the edge here, turning off tangent chain and pulling it right to the end. Now it's time to start extruding surfaces, trimming and merging with the stitch feature. I won't fully enclose this shape though, because I will merge it in with the other surfaces later on. I'm going to start with creating the back surface. I'm going to keep it simple with a straight edge. I'll just use the offset feature to create the top surface. And then relative to the Z plane, I'll start sketching the profile of the arms that I want to be connecting the two bosses to the pillion peg. Now we'll extrude these surfaces separately, and then we can start trimming away the rear and top surfaces, and then also trimming away the extended material of these profile surfaces. Eventually we'll have something looking like this. Now there'll just be some stitching and trimming of various surfaces to join the existing quilts together. Now, in order to get one surface to fill the back of this part, I'm just going to repeat the earlier extrusion, trim away the outer profile, and then stitch it into the remaining quilt. Now I want to work on the mount features, so I want to remove these extended cylinders and just make this a straight surface on the top. Since these are external surfaces, we're going to have internal surfaces here as well, so that would be the next part to model in order to create this. So we can make many things in various different ways. So in this case, I'll make the internal surface with an extrusion from the side. And since I need two separate surfaces for this, I'll make the second one using a different feature. So I'll use the fill, and then I will offset that to get the internal surface. Now it's just a case of stitching everything together. And then adding that rear surface back in. Then we stitch it all together and we have our solid part. Now I'm going to start working on the design of the part now. I'm going to be using some fillets and chamfers to create a more interesting shape. So whilst I'm doing that, I thought I'd take the time to talk from the perspective of someone that's now a hobbyist, now out of industry. Something to remember is that if you are working on a project, you'll be working on that project for 2 or 3 years. You may only design and model one pillion hanger throughout that whole period. You may make some modifications throughout the time, and of course be modeling other parts. But to really build up the experience and the efficiency for modeling a single part, We have the benefit as hobbyists of being free to model it as many times as we want. We can play with the styling as much as we want. We don't have the input from a styling team that we have to abide by. We can make mistakes and scrap the whole design as many times as it takes. All this does is adds to our experience. So for example, I could sit and model one of these pillion hangers every day for the next 2 weeks, every time improving my methods, potentially improving the design, and also slowly build in the manufacturing constraints. So let's say, for example, 5 out of 10 of those are up to the standards to be manufactured for production. Now from my experience it doesn't really work like this, but let's say that one person has been modeling pillion hangers for 15 years, and let's say each project takes 3 years. They're not modeling just pillion hangers, they are modeling other parts, but over the course of 15 years they would have produced 5 sets of pillion hangers. Now we can compare that to our 10 sets over the course of 2 to 3 weeks. Just cutting in back to the model, here I start to add the machine features. So yeah, these 10 models that we may produce, they may not be as complete in detail as a production pillion hanger, but we can get very close. And we can also start practicing the drawings and structural analysis. So I really think this is one of the advantages of having the experience as a hobbyist working on these kind of projects. We can get a lot of relevant experience just by repeating these processes. So it's coming along, but we are still missing some details. You'll see most pillion hangers will have this heel plate. So I'm going to try and add one in. So I'm starting with a simple sketch and extrusion. And eventually we're going to shell it and add some rounds. But this shape isn't quite there. We can make this shape a little bit more interesting by using extrusion from another angle. So I'll do what I did previously. I'll create a plane on this curve or on this edge, and then I will sketch a profile which I want to kind of cut away from this geometry here. When we extrude this profile, we'll use the intersection setting, and that will combine the two extrusions, and this can give you a more interesting shape in some cases. Okay, so it's a little bit plain. So I'm going to cut some features into this part, and I'm going to do that by offsetting a plane from this face, then drawing those sketches onto this plane, and then extruding it into the body. In this case I can extrude this as a body, which I'm then going to use to cut out of the plate. So once I have the initial cut, I'll add some rounds and a draft. Then when we have a shape that we're happy with, we'll combine them. So now you can see how it looks. I'll just come in and fine tune this sketch. So I use a construction line to help to control the angle of the cut, and then I'll also use that to drive a pattern. So here I'll be using the rectangular pattern feature. You can use this to make multiple rows and columns and repeat that pattern, but in this case I just make a single line. Now there are other ways of creating this kind of feature. Using this method means that I'll have to create each body individually and then add the rounds afterwards. Which means they then have to go in, apply those rounds to each part, and then also modify the cut feature to include all of these cut features too. Okay, so now I'm roughly happy with that. I just need to reposition it back to the pillion hanger itself. Now it's going to be kind of tricky to get this perfect, so what I'm going to do is I'm just going to have it with a slight overhang, and then I'm going to use the split body feature to split the body of the heel plate using the flat face on the back of the pillion peg mounting part. You can then hide off or delete the body that is remaining. It's no longer needed. You then merge the shapes together using the combine, and then just tidy it up with some rounds where we have these sharp edges. So if you take a look at the rear pillion hangers of some other motorcycles, you'll see they'll usually have some material cut away in the back. This is for weight saving. Okay, so this shape is no longer suitable to be able to use the shell feature to thin the material. So I'm going to use some sketch offsets to create the profile, which I'll extrude and cut out the back of the pillion hanger. We can extrude this profile in multiple different ways, but I wanted to extrude it to a depth which is consistent throughout the part. So for that I'm going to use a plane offset, and then I'm going to extrude to that object. So when I extrude this profile, I'm going to extrude it as a new body, and then I'm going to apply the round details to this body before I merge it into the component. Now for this first profile, we actually resulted in a small hole being present in the body, so I need to come back in and modify the sketch to avoid this. So with this cut feature fixed, I'll have my final version of my part. So for each part that I design in this channel, I'm going to make multiple versions. One reason for that is that as you model things multiple times, you find better processes for making that model. Also, they'll be constructed in different ways. Something as simple as the mounting orientation of the bosses can greatly change the whole part. And in some cases I'm going to be trying to make some more unique custom designs. If you stuck around to the end, thank you very much for watching. So please like and subscribe if you're interested to see more. And if there's anything particular you'd like to see, please leave a comment down below.